Okay, good evening, everybody. Tonight we're going to be doing simplifying square roots, and there's quite a bit of rules need to apply yourself and work on memorizing because it can get quite tricky. Which when it's okay to do one thing, when it's not okay to do another thing. So I'm going to go ahead and jump right in here. So when we look at this, we see we have the square root of 7 plus the square root of 9. If we think back a couple of lessons ago, we talked about this, and we treat the square root symbol right here the same as we do in order of operations as a group. So since this is a group, that means I can do what's inside the group first. So that would be equal then to the square root of 7 plus 9 is 16, and the square root of 16, of course, is 4. So that means the square root of 7 plus 9 is equal to 4 because those are both inside a group. Okay, so that's one thing. Now, the second one here, they're not inside the same group. So I'm going to keep going down my order of operations, and I see that neither one of these can I take the square root of. I don't know the square root of 9, or excuse me, 18. I don't know the square root of 9, of 2. So I'm just going to multiply them. I can multiply these together. I cannot add two different square roots together, but I can multiply two different square roots together. So that's going to be equal to the square root of 18 times 2 is 36, which is equal to the square root of 6. Okay, so that's perfectly okay. Now, something that I'm going to well, maybe I'll hold off on that. Okay, so there we go. So that's that. Now, looking at the last one down here, I have the square root of 25 over the square root of 7. And I noticed that unlike this one, I could do this little problem inside here. I can't divide 7 into 25. It doesn't give me a number, a whole number. It gives me a decimal or a mixed number. So there's no use doing that. But I do notice that I have 25 on top, which I kind of like. So that means I can rewrite this like this. It's perfectly okay, just like we had this problem written as two different multiplication problems. It's perfectly okay to have the square root of 25 over the square root of 7. And having it written that way, I know the square root of 25, which is 5 over, I don't know the square root of 7. So that's perfectly okay. I'm going to jump back here, and I suggest you put some fifth color in. This is not okay. The square root of 7 plus 9 does not equal the square root of 7 plus the square root of 9. So while this is okay to do here, to split this problem into two separate square roots, it's not okay to split this problem into two different square roots. So this is one of the rules or the understandings we have to do, is that here I'm adding two numbers together and then taking the square root. I cannot separate them in two separate. If we kind of think about that, it kind of makes sense because the square root of 9 would be 3, and I don't know what the square root of 7 is, but I know it's not 1. So if the answer is supposed to be equal to 4, then this number here would need to be a 1, and we know that square root of 7 does not equal 1, which is why this whole thing does not equal each other. Okay, let's take a look at the next problem then, or next slide. Alright, so what we're going to do here is we're going to simplify these even though they're not perfect squares. So instead of estimating like we did yesterday, we're going to simplify them. So what I noticed first is I don't know what the square root of 75 is. It's not one of my perfect squares that I've memorized. But thinking back to what we did a second ago, I can break 75 down into the square root of, and when I think about what multiplies to give me 75 that are perfect squares, well, I know that 25 does. 25 times 3. So the square root of 25 times 3 can be broken into the square root of 25 times the square root of 3. And I know the square root of 25. The square root of 25 is 5, and I don't know the square root of 3, so then I just leave it 5 times, or 5 on the square root of 3. This would be my simplified answer right here. Okay, I'm going to do a similar thing here. I don't know the square root of 8, so I could estimate it, but I don't want to estimate it. I want to leave it in exact form. This, by the way, is exact form here. This is the exact form. This is exactly what it equals. There's no about symbol. It's exactly equal to that. So here I want to leave this in exact form, so I'm going to break it down into, and I think about what multiplies together to give me 8 that are perfect squares. So 4 times 2, and the square root of 4, I could break this into the square root of 4 times the square root of 2, and of course the square root of 4 is equal to 2, and I don't know the square root of 2, so I leave it 2 on the square root of 2. Again, this being my exact answer. So the square root of 8 is equal to 2 on the square root of 2. And one more example here. We're going to break this into 100 times 3. And of course that breaks into the square root of 100 times the square root of 3. The square root of 100 is equal to 10, and I don't know the square root of 3, so I just leave it. Notice that each time I put the number on the outside that has a perfect square. So I like to do my perfect square first and my non-perfect square last. Perfect square first, non-perfect square last. Perfect square first, non-perfect square last. That way when I split it up into these two, I have the square root of 5 in front, and then the square root of 3, square root of 2 in front, and then on the square root of 2, square root of 100 in front, so that's 10 on the square root of 3. Okay, so that's just my preference. Alright, and our last slide. Okay, so here we're going to take a look at when is it okay for us to do some stuff. And here's what I want you to think of. Think back to when we were doing combining like terms. Think of this as a term. It's like x or y. If these two things are the same, if the two square roots are the same, then it's okay. So I didn't see that I had stopped recording. I have no idea where I stopped, so I'm going to go back and say what I said. I don't know what you guys saw. So if this is repeat, I apologize. So the thing that we want to notice on these is that my square root symbols are the same. I said that this is kind of like having x here and x here. If I have x's, then I can combine these like terms. So if I have the same square root symbol, then I can combine these together. So a square root of 3 and the square root of 3, that means I can add 4 plus 2 and give me 6. Okay, so that's perfectly okay, and this would be my final answer. Now, on this one, what I was mentioning is I do have the same square root symbol, but the tricky thing is what number is in front of this square root of 7 here? It can't be a 0, because if it was 0 here, 0 times the square root of 7 is equal to 0, and that doesn't make sense. This isn't equal to 0, it's equal to the square root of 7. Therefore, there must be a 1 in front. And in fact, we've learned that before, that anytime I don't see a number, there's actually a 1 there. So then, I have the same square root symbol. Therefore, I can add this one to this one, which means I have the square root of 7, and then I have 1 minus 8, which gives me negative 7. So my answer is negative 7 on the square root of 7. The third one down here, I noticed that I have the same 3's here. So it seems like, oh sweet, they're the same, therefore I can add them together. But remember, what's important is not the number in front, it's the number inside the square root symbol. So the fact that this square root of 3 and this square root of 3, I can now add those 4's together. Square root of 7, square root of 7, I can subtract those two numbers. Here, I have the square root of 8 and the square root of 10. Those are not the same square roots. Therefore, that's my answer right there. There's nothing else I can do. I'm done right there. So I can't add anything together. Don't write 6 or anything like that. Alright, and the last one we're going to do down here is you see that I have a fraction that I'm adding together, and what I should notice first is that I have the same denominators. That's good. We like that. So anytime I have the same denominators, that means I can add my numerators together. So my denominator is going to be 5. Now, going back to this idea, if these are the same, I can add them together. If they're not the same, then I can't add them together. This is the square root of 7. This is no square root at all. Therefore, I cannot add them together. So then my answer is going to be the square root of 7 plus 3 over 5. And that's my final answer. Okay? So there we go. So that's simplifying different types of square roots. the rules are confusing. You gotta put some effort into it to try and keep them straight. Make sure you write lots of fifth color, and I will see you guys tomorrow.